We are in section 7.2 continued. This is on the top of page 6. So the example says determine the following, and we are going to round 3 decimal places. So the first one says, part A, find the t value such that the area in the right tail is 0.02. So we need to find the value of t. So here's our t, where this area in this little right tail is 0.02. So in order to do this, we need to have inverse t. So our t value is going to equal inverse t. It's the area to the left, and the area to the left is going to be, because the total area and under the curve is 1, is 0.98. So I'm going to put in 0.98, comma, degrees of freedom, and it tells us that there's 19 degrees of freedom. Again, the directions are up above on how to use your calculator. Going to second, vars. For me, it was number 4, inverse t. Again, that's around 3 decimal places on this. So for the answer here, I have is 2.205. Let's try the next one. Next one says find the t value such that the area to the right tail is 0.10. This time 32 degrees of freedom. So the area in the right tail, which is what we had up above, this time we have a little bit more, so the area in the right tail is 0.10. And so in order for us to find our t value, we have inverse t, the area in the left. So if that's total area is 1, that's 0.10, then to the left would be 0.90. And so we're going to have 0.90, comma, degrees of freedom, which is 32. And again, second, vars. Let's go ahead and round 3 decimal places, and we get 1.309. These are both positive values, and the reason why is because they're to the right of the mean. The mean is at the center. Part C says find the t value such that the area to the left of the t value is 0.05 with 6 degrees of freedom. So area to the left is going to be 0.05. So in order to calculate our t value, we have t equals inverse t. Area to the left is what we need, so 0.05, comma, degrees of freedom, which is 6. Again, this is values to the left of the mean, so it should be negative. Rounding 3 decimal places, it's negative 1.943. There's one more part down here. It says find the critical values that correspond to 95% confidence. So because we're dealing with confidence, again, confidence is always in the middle. So we're going to have 0.95 here. And that means 1 minus 0.95 is 0.05. And since it's getting split into 2 tails, dividing that by 2 is going to be 0.025 in both of those tails. So 0.025. And then 0.025. So we're going to have the first value down here, which will be our T1. We'll call the second one T2. And again, because this is symmetric, they should be the same value, but one's going to be positive, which will be T2, and the other one would be negative, which is T1. So let's go ahead and calculate T1. So this is going to be inverse norm, inverse t, not norm. Area to the left is going to be 0.025, comma, degrees of freedom is 16. And then to calculate T2, we have inverse t. And the area to the left is going to have to be added up, which is going to be 0.95 plus the 0.025, which is going to be 0.975, comma 16. Working both of those out, you get negative 2.120 and positive 2.120. Right below this is constructing confidence intervals using a calculator. So first thing is to verify that the test and actually conducting a confidence interval can be done. That's verifying it's a simple random sample and that our size is greater than 30. Next thing is stats, test, and t-interval. I want you guys to notice there is a little note over here that you do use z-interval if sigma is known, but for most of them it's going to be t-interval. If the data is raw, you highlight data and put all the numbers into L1 and set the list to L1 and frequency to 1. In summary statistics are known, we're going to highlight stats and enter in statistics. You're going to enter in your confidence level, hit calculate, and your answer is going to give you the lower limit and your upper limit, and then we do need to interpret. So looking at the next page, on page 7, there is an example here that we're going to look at. It says the summary statistics for randomly selected weights of newborn girls and is 205, X bar is 30.4 hectograms, S is 7.1 hectograms, and sigma is 6.9 hectograms. So it does tell us sigma in this problem. And so because it tells us sigma in the problem, we actually use a standard normal distribution, which is z. So the confidence level here is 95%, and it tells us to round 3 decimal places. Part A says find either the critical value, t alpha over 2, or the critical value, z alpha over 2. And again, we use z this time because sigma is known. So we have z alpha over 2 is equal to, and so we need to figure out our alpha value. And our alpha value is just 1 minus our confidence level, which was written earlier in section 7.1, which is going to be 1 minus 0.95, which is going to be 0.05. And since it's alpha divided by 2, we're going to have z. 0.05 divided by 2 is 0.025. In order to figure this out, we use inverse norm, because again, this is a standard normal distribution. Area to the left, which is going to be 0.025. The mean, which is 0, and the standard deviation, which is 1. So see if you guys can calculate that. The next part says to construct a confidence interval for the mean. So again, because we do know our standard deviation for the population, which is sigma, we're going to use, and for me it was number 7, which was z interval. And so go ahead and see if you guys can try this problem on your own. Down at the bottom, there are some more formulas that I want to look at with you guys. So we're going to go ahead and give this a star. This is determining the sample size n, which we saw back in 7.1, but 7.1 was when you were dealing with proportions. This time we are dealing with the mean. So the required sample size required to estimate the population mean, mu, is given by z alpha over 2 times sigma divided by e squared. So again, that z alpha over 2 is at the bottom of page 2 in your notes for chapter 7. And e is our upper bound, lower bound, subtracting m divided by 2. Since n is our population, or our sample size, we are going to round up to the nearest whole number. And then we have a couple things down here to star. What could be done to increase the precision of the confidence interval? You could increase the sample